In this video, we're going to be focusing on Venn diagrams. First, I am going to review how to make a Venn diagram based on a verbal description. Then I will show you how to make the same Venn diagram using values of probability instead of values of frequency. After that, we will use the new Venn diagram to calculate 8 different probability statements on the following pages. Let's start by filling in the Venn diagram labeled with frequency. Frequency means that we are going to count the number of people that fall into each section of the diagram based on the information given in the description. In this example, we are observing people at a neighborhood park. As you can see, the Venn diagram has already been labeled with an S on the left circle to represent people wearing sneakers and an H on the right circle to represent people wearing a hat. The first piece of information is that there are 25 people total. One thing you should remember about Venn diagrams is that we never put the total number into the diagram. I will make note of the total being 25 below my diagram. I need to make sure that the numbers in each section of the diagram add up to my total of 25 people. Next, we are told that 11 people are wearing sneakers. You might be tempted to put the 11 here in the left circle because it's labeled with an S for sneakers. However, what we're really being told is that 11 people total are wearing sneakers. That means the number of people just wearing sneakers plus the number of people wearing sneakers and a hat needs to add up to a total of 11 in this whole circle. So I'm just going to write an 11 at the top so that I remember everything in that circle should add up to 11. Next, we're told that 8 people are wearing both sneakers and a hat. That means that this 8 goes in the overlapping section, where people are wearing sneakers and a hat. Next, we are told that 10 people are wearing hats. Once again, that means that everything in the right circle needs to add up to 10. So I'm just going to write a 10 at the top so that I make sure the numbers total in my right circle add up to 10. I'm going to have to also figure out the number of people that go outside of these two circles. In other words, the people that are not wearing sneakers or a hat. Let's start with this blank on the left. If I know that 11 people total are wearing sneakers and 8 of them are wearing sneakers and a hat, then 3 people must be wearing only sneakers. I can check that by doing 8 plus 3, which is 11. Also, since I know that 10 people total are wearing hats and 8 people are wearing sneakers and a hat, there must be 2 people wearing only a hat. I can check that by doing 8 plus 2, which gives me 10 total in this circle. Now, to figure out the number of people that are not wearing sneakers or a hat, I need to count the people I have so far. I have 3 plus 8 plus 2, which is 13 people. However, there are 25 people in the park. So if 13 people are accounted for, there must be 12 more people in the park who are not wearing sneakers or a hat. Now, if I add all these up, 12 plus 3 plus 8 plus 2, it does give me 25. Now, to make a Venn diagram labeled with probability, I need to go through each section of the diagram, take the number of people in the section, and divide it by my total. That's going to give me a decimal, which represents the probability of somebody falling into each of the sections. I'll start with the 12 in the bottom left corner. I can take 12, divide it by my total of 25. That gives me the probability of not wearing sneakers or a hat, which is 0.48. Next, I'll take the 3 in the left circle, divide it by my total of 25. That gives me 0.12, which would be the probability of someone only wearing sneakers. Next, I'll take the 8 in the overlapping section, divide it by the total of 25. That gives me 0.32, which is the probability of wearing sneakers and a hat. Lastly, I'll take the 2 in my right circle, divide it by 25, and that gives me the probability of 0.08 of someone wearing only a hat. I can check my work by adding all of these probabilities up, and they should add up to the value of 1. The reason for that is because the biggest possible probability you can have is 1. And since everybody in the park has to fall into one of these categories, the probability of being in any of the categories would have to be 1. And if you do this in a calculator, you'll see that these decimals do add up to a total of 1. So that's a good way to check your work. Now I have the same diagram we just made copied on each problem. I've also shaded in the event that we'll be focusing on for each probability statement. For the first one, we're looking at the probability of event S, which is wearing sneakers. So I've shaded in the circle labeled with an S. To To find the probability of someone wearing sneakers, I need to add the probability of wearing only sneakers with the probability of wearing sneakers and a hat. So 0.12 plus 0.32 gives me 0.44, which is the probability of wearing sneakers. Next, I'm looking at the event S complement. This C represents the word complement. Complement means we're looking at everything that is not in the given event. So I'm looking for the probability of someone not wearing sneakers. To do that, I've shaded in everything outside of the circle labeled with an S. Now, once again, I can just add up the probabilities in my shaded area. So 0.08 plus 0.48 gives me 0.56. There's one other way to calculate a complement. I know that the probability total needs to add up to 1, and I've already figured out the probability of wearing sneakers. That's 0.44. So therefore, the probability of not wearing sneakers should be the total, 1 minus the probability of wearing sneakers. So 1 minus 0.44 gives me 0.56, which is the same as the answer I already got. So you can either add up the probabilities in the shaded area, or you can take the probability of wearing sneakers and subtract it from 1 to get the probability of not wearing sneakers. And then you can always use the other method just to check your work. Next, we're focusing on event H, which is wearing a hat. So the probability of wearing a hat is going to be the probability of wearing only a hat plus the probability of wearing a hat and sneakers. So 0.32 plus 0.08 gives me 0.40, the probability of wearing a hat. Now we're looking at another complement event. We're looking at the event H complement, which means the people not wearing a hat. So I've shaded everything in outside of the circle labeled with an H. Once again, I can add up the probabilities in my shaded area. 0.12 plus 0.48, that gives me 0.60. And I can check this by taking my total probability, which is 1, and subtracting the probability of wearing a hat, which is 0.40. And that does give me 0.60, the probability of not wearing a hat. Our next event is SUH. This U represents the word union, which we can also think of as the word or. So it means we're looking for the probability that someone is wearing sneakers or wearing a hat. The union of the two events in a Venn diagram is just everything shaded in both circles. So to find the probability of a union, I can add up the probability in each of these sections. So 0.12 plus 0.32 plus 0.08, that gives me 0.52, the probability of wearing sneakers or a hat. My next event is S upside down U, H. The upside down U represents an intersection, which we can also think of as the word and. So that means I'm looking for the probability of wearing sneakers and a hat. For this one, I don't even have to do any math. I already have my intersection as my overlapping area here. So the probability of wearing sneakers and a hat is just 0.32. Now we have two conditional statements to calculate. The first one is the event S given H. That means I'm looking for the probability of someone wearing sneakers given they're wearing a hat. Now, if you think back to the last video on two-way tables and conditional probability, we use something called the circle and check method. We're going to do that again here. So I always circle the part that's focusing on my given. My given here is H, which represents wearing a hat. So I'm only going to focus on the numbers in my given section, which is wearing a hat. Now I need to check the probability that I'm interested in, and I'm interested in the probability of wearing sneakers given they're wearing a hat. So within my circle, which probability represents people wearing sneakers? That's going to be the one in the overlapping section. So to calculate my conditional probability, my denominator needs to be the total probability in the area I've circled. So that's 0.32 plus 0.08. And then my numerator is the probability I want to know, which is the probability of wearing sneakers within the wearing a hat section. So I already have that checked off, which is 0.32. Now I can just simplify this to 0.32 divided by 0.40, And if I do that in my calculator, that will give me 0.8. Now, if you remember, this connects back to our conditional formula. Our numerator was the overlapping section, which is the probability of wearing sneakers and a hat. We already found that in the previous example. And our denominator was the total probability of wearing a hat. So this method that we use matches up with our conditional probability formula. For the next example, I'm going to use this formula to calculate from the beginning. So if I'm looking for the probability of H given S, that means the probability of wearing a hat given you're wearing sneakers. So this time our given event is S. So I'm going to circle the numbers that are just a part of the event S. Now I need to check the portion of these numbers that is the probability of just wearing a hat within wearing sneakers. So I'm going to go to the overlapping section because that's the portion that is wearing a hat and wearing sneakers. Again, I can think of this as the probability of both events, so H and S, or wearing a hat and sneakers, divided by the probability of my given event, which is wearing sneakers. So I've already figured out that the intersection in my numerator is 0.32, and my denominator is the total probability of wearing sneakers, which is 0.12 plus 0.32. Now I can simplify that to 0.32 divided by 0.44. And if I do that in my calculator, I get 0.73.